Okay, we're in section 2.3, and I'm going to do problem number 11. And it says R of t is t to the t, and S of t is arc cosine or cosine inverse of t. And it gives the derivative of those two, and it says if W of t equals t to the t times cosine inverse of t, what's W prime? So these are a product, and so I have to use the product rule. Derivative of the first, so I have to look up here and see what the derivative is, and that's t to the t ln t plus 1, and that ln plus 1, ln t plus 1 is in parentheses. That's the derivative of the first times the second plus derivative of the second, and the derivative of the arc cosine is, or the cosine inverse is, negative 1 over the square root of 1 minus t squared times the first. Okay? And I could factor out the t to the t if I wanted, but that's all they ask for is determine what it is, so I've got that. The next question says, write equation for the tangent line of WT. So the tangent line, and this is at a equal 1/2. So it's W prime of 1/2, so derivative at 1/2 times x minus 1/2 plus W of 1/2. So I need to work that out. So I need to figure out what this is at 1/2. And I've pre-typed in these functions into my calculator, so I can get it there. So you can see the four functions there. And now to do this, I need the y3, and we're doing these all at 1/2. So I'm going to go to my table, and let's label this. This was in y1. This was in y2. The derivative of y1 is in y3, and the derivative of y2 is in y4. Let's go back and check that. y1, y2, y3, y4. Okay? So by doing that, and then if I go to the table and delete all these, and I'm just looking at 0.5. So let's see if I can set that somewhere where you can see the table and slide this over. And the first thing I have is t to the t, and that's 0.7071. Y2 is this thing, and that's 1.0472. And then y3 is the derivative of this. That's this one with a half, and there's 0.217. And y4 is minus 1.155. And that was all of that because it had the minus in there already. So all I have to do is work out this to get that derivative. So second quit. Looks like you could kind of see what I'm doing there. So I got to take 0.217 times 1.0472 plus a minus, so just minus 1.155 times 0.7071, and I get the first derivative of a half is negative 0.533534, close enough, times x minus 1/2 plus w. Well, it's just these two, so it's y1 and y2 multiplied, y1 and y2. So I just got to take these two and multiply them for this part out here. So that's 0.7071 times 1.0472, and I get 0.740-ish. Okay? All right. I just wanted to show you how you could use your calculator and your tables to help you with this. Now, if v of t is this quotient, is t to the t over cosine inverse of t. You've got to find out if it's increasing or decreasing. So we want to know whether the derivative is positive or negative. Positive, it would be increasing. Negative slope would be decreasing. So we've got to find the derivative of this. So v prime of t would be derivative of the first, ln t plus 1, derivative of the first times the second, which is cosine inverse of t, minus derivative of the denominator, which is minus 1 over the square root of 1 minus t squared times the numerator, and all of that divided by the denominator, cosine inverse of t squared. Now we have all these numbers already. This first number is 0.217. Cosine inverse is 1.0472, and now it's minus, and this quantity is negative 1.155 times 0.7071, all divided by the cosine inverse, which is this 1.0472 squared. So all I have to do is work that out. And I think you can see everything there. So parenthesis 0.217 times 1.0472 minus a minus is going to be plus 1.155 times 0.7071. That's my numerator, and I've been close to parentheses, divided by 1.0472 squared. And I get 0.95, which is greater than 0, so it was increasing. Okay.